The CLO for this lesson is that students will be able to convert in writing between radians and degrees using the unit circle and formulas, as well as the following language: if-then statements, trigonometry, angle, degree, and radian. So in your own words, what do you think you're going to learn how to do in this lesson?
All right, so welcome to our notes on trig, and this is the first lesson into trigonometry. Trig is just the short word for trigonometry. And this whole unit is about trigonometry, and trigonometry is actually its own type of math. Trigonometry is technically the mathematics of angles. Yes, I know, I spelled the word. Mathematics. Okay, mathematics of angles. So here's what I mean by that. When you think of algebra with like solving for x and stuff, that's usually the math of money, because what it applies to the most in real life is money. And then you have geometry, which is the mathematics of shapes. And so it's like in geometry, you learn all about the shapes and how shapes work. And then probability and statistics, those are like the mathematics of data, and it's like analyzing data, and that's like what it's about, the topic. And the topic of trigonometry is the mathematics of angles. Well, remember, an angle is the distance between two touching lines. So I'm going to go ahead and jump over here real fast and start drawing. So if I were to draw an angle, I would need one line. It's not quite an angle yet. Pretend that's straight. But then once I have a second line, the angle is here. I'm going to change the color to show you the angle. The angle is this distance between the two lines, and like how far apart these two lines are. And so you can measure angles in two ways. The most common way you know how to measure an angle is in a degree. Degrees are what you know. It's like what we've talked about. There's 90-degree angles, 180, 360 is a whole circle. There's all the degrees. And so degree is a way to measure angles. So, but you know how you can measure your height in like feet, but you could also do it in inches or in centimeters or in meters. Like there's tons of ways to measure your height. It's not just one. So angles, there's two ways to measure them. There's degrees, and then there's also radians. And so radians is also a way to measure angles. And just like they expect you to be able to go back and forth between like your height in feet versus your height in inches, they expect you to be able to go back and forth between measuring an angle in degrees and in radians. So that's the point of these whole notes. And total is how do you go between a radian and a degree. And that's going to be what the worksheet asks you to do and everything. However, before we get there, there's going to be a lot of me explaining the base of trig. So I'm going to explain the unit circle next. And the unit circle is a base fact in trigonometry that you have to understand that will help you understand the rest of the unit. However, this whole first explanation, you're not going to have to recreate it. It's not like you're going to have to do math with it. It's just for you to understand. Okay. So I'm going to start by explaining radians. So if I come over here, radian should sound like the word radius to you. And if you remember, the word radius means this. If I were to take a circle and find the direct center of the circle, pretend it's right here. It's not perfect, but pretend this is my center. And if I were to measure, like take a string and measure how long it was all the way to the edge of my circle, that would be called my radius. And so a radian is the length of one radius in a circle. So when we work with angles, we usually put this unit circle on an x and y axis like this. And right in the middle is the center of the circle. And then this is one radius. And this line is usually where we start. So if I'm drawing my two lines to make an angle, this is usually the first one. And this is like flat. This is 0. So if that's 0, if it moves 0 degrees or 0 radians, it's right in the same place. It would be right here. And that's having no angle at all because it's right on top of itself. So if I want 1 radian, what I'm going to do is I'm going to take this length here of my radius, and I'm going to start at 0, and I'm going to take that length along my circle, and it would go to about right here. And so this, if I were to connect it, boop, 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 this is my angle of about 1 radian. One radian. And then if I were to go another whole radian, like if I were to take that string and go again about the exact same length, it would take me to about here. So this would be at 2. If I were to go again, this would be at 3. Another little length makes this about 4 radians. Go again, that's about 5 radians. This is about where 6 radians would be. And then if I were to go all the way around the whole circle to end back where I started, it'd be 6.28 radians. And I know that because I was told that. And I measured it with a string one time, but I'm not going to make you guys do that. Just trust me that the whole circle is 6.28 radians. Which is very little in comparison to degrees. Like if you remember, a whole circle has 360 degrees. So this whole thing, if I were to do it in degrees, would be 360 degrees. 60 degrees. Where it's only 6.28 radians. Which means 1 degree is like that much. Versus 1 radian was all the way up here. So radians are a lot bigger than degrees are. And so that is the concept of what a radian is. However, if the whole circle is 6.28 radians, if I were to cut that in half, that meant this half a circle, half of 6 is 3, point, half of 2 is 1, half of 8 is 4. So half of a circle is 3.14 radians then. And 3.14 is a special number in the math world called pi. And the pi symbol looks like this. If you've never seen pi before, let me know and we can talk more about pi. But it's just a symbol that we use for the number. It's not just 3.14. If I were to type in pi, it looks like this, and it's 3.1415926, blah, 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 blah. It keeps going. And it's a special number that shows up a lot in real life in circles and stuff, like in the circumference of the circle and the area of the circle. And because of how often it shows up, they gave it its own little special symbol called pi, which looks like this. And radians, they actually measure with pies more than they do with like 3.14 radians. Like they would rather say we have pi radians, which brings us into creating the unit circle. So the unit circle, we're going to do it in both radians and degrees as we create it. You always want to start with your 0 line. Like here's where I start. And so if I start in degrees, it's at 0 degrees. And if I start in radians, I'd be at 0 pi, because I have no pi's. And then if I take my line and I go to half of a circle, remember the full circle, if I went all the way back around and ended up, like if I took it and went all the way around the circle, and ended up back here, I would have 360 degrees. So if I cut that in half for half of a circle, I get 180 degrees. So if this didn't go all the way around the circle, but instead only went halfway, and ended up over here, it'd be 180 degrees. And that's half a circle. It's also a straight line, if you see that, with this line over to the next line. Together, they make this straight line because 180 degrees was our straight line pair back from Unit 2. So now if I did the same thing for radians, if I went all the way around my circle and ended up back here, remember the whole circle was 6.28 radians, which if half the circle was 1 pi, the second half of the circle makes it become 2 pi's. So for a whole circle, you have 2 pi radians. But then for half the circle, if I only went 180 degrees, that's the same thing as going 1 pi radian. However, the unit circle doesn't just get cut in half, it gets cut in a lot of ways. So if we continue to scroll down, you can see it here. Now it's being cut into 4 pieces. So I'm going to start with my 0 line. I can never make these straight. 0 degrees. Zero pi's for radians. And I'm going to fill in the ones we already did. So this one, and this one, if it goes all the way back around, it's at 360 degrees. But half of that was 180. And with pi, the whole thing was 2 pi's. But half of that was 1 pi for half of my circle. All right. So now I'm going to go ahead and add in what happens if I take 180 and cut that in half. Because if you look, like at the top half of the circle, this line dividing it into making 4 parts is like half of the 180. And half of 180 is 90. Also, you can think of it as the whole 360 getting divided into 4 pieces, which is also 90 degrees. Which means right here, this is 90. From 0 up to here is 90. And you know this is a 90-degree angle. You see how that makes that perfect little square in there between the 0 degrees and the 90 degrees? Then if I do another 90, I'm at 180. But if I did another 90 degrees down here for this line, I'd be at 270. And then if I add 90 degrees again, boop, I get the 360. So to do it in radians, if half of my circle is pi, half of that, we just write it as a fraction. It's going to look weird. It's pi over 2, because I'm taking the pi and I'm dividing it in half. So that's from 0 degrees up to 90 degrees. Is the same thing as pi over 2. So note that 90 is the same thing as pi over 2. If I do another pi over 2, then I have, at the 180 degrees, I would have 2 pi over 2, because I'd have 2 of them. But 2 divided by 2 is just 1 pi, just like how 180 was just 1 pi. Then if I add another one for the one equivalent to 270, it becomes, I have 3 pi over 2's. So here's 1 pi over 2, 2 pi over 2, which is the same thing as pi. Then 3 pi over 2. And if I go another 90 degrees, I have now officially 4 pi over 2's. But if I do 4 divided by 2, I just get the 2 pi's. So this is what happens when you divide the unit circle into fourths. They also divide it into eighths. So again, I'm going to quickly just run through and without talking, fill in everything that we already know. So that's what we knew in our degrees. I'm going to come over here and do what we knew in our radians. So I'm not going to write 2 pi over 2 because that just reduces the pi, and the most reduced form is always the best one. Again, I'm not going to write 4 pi over 2 over here because it's just the same thing as the 2 pi's. Okay. So now we're dividing it into 8. So if I took my whole circle, the whole 360, I divide it by 8. We find out each eighth was 45 degrees, which means that this one here is 45 degrees. If you add 45, you get 90. You add 45 again, you get 135. You add 45 again, you get 180. If you add 45 again, you get 225. You add 45 again, you get 270. 45 again brings me to 315. And then my last 45 brings me back to the 360. So then if I did it in radians, this upper half, this pi, is now getting split into 1, 2, 3, 4 pieces. So one of these is a pi over 4. This is 2 pi over 4, but 2 pi over 4, if you reduce it, 2 divided by 2 just becomes the 1 pi. 4 divided by 2 becomes the pi over 2, or the 2. So that this is the exact same fraction, 2 pi over 4 is the exact same fraction as pi over 2. So it's better to write it like this than like this, but it's 2 of the pi over 4s. So this is my third pi over 4. This is my fourth pi over 4, but again, 4 pi over 4. 4 divided by 4 just becomes 1 pi. This is 5 pi over 4. This one is 6 pi over 4. But, wow, that pi looks weird. Pi. All right. If I do 6 divided by 2, I get 3. If I do 4 divided by 2, I get 2. So these are the same fraction. This is my 7th pi over 4. I'm going to circle this because it's one number, despite how it looks. All right. And this 2 pi would be my 8th pi over 4. But again, 8 pi divided by 4 just becomes 2 pi. And it's better to write it in its simplified form. So that's dividing it into 8s. Sadly, we can also divide it into 6 and into 12s. And then we can put it all together. So I'm going to try to go a little bit quicker. So if I'm dividing it into 6, this would be 180. Here, I'm just going to divide it into 6. So when I do divided by 6, it's 60 degrees each. So this is 60 because we just realized that dividing it in 1, 2, 3, 4, 5, 6 pieces, each one 60. 60 more makes this 120. 60 more is 180. 60 more is 240. 60 more is 300. And then 60 more would take me back to my full circle all the way around, which is 360 degrees. if we're measuring in degrees. Now, if I ask you to measure in radians, when you start right here, without moving, you're at 0 pi. Note that if this is 1 pi, on top then, it's going to divide into 1, 2, 3 pieces. So this is a pi over 3. So pi over 3 is the same thing as 60 degrees. Another one would be 2 pi over 3s. Another one would be 3 pi over 3s, but 3 over 3 is just pi. 3 pi over 3s. Wow. Writing on the computer is hard, y'all. Right, and one more would be 6 pi over 3, but remember 6 pi divided by 3 just becomes 2 pi's. And then they can take these and divide these all in half too, which would divide them into 12s. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to run through in degrees. 0 degrees. When you start, you divide this into 12 pieces, you get 30 pieces, 30 degrees each for each little piece. So that means this one's 30, one more 60. And note that this line, this 60 degrees right here, same exact place as the 60 degrees above it. Like if I went up here, see, this line is in the same place as that 60 degrees. 30 more is 90. 30 more is 120. 30 more is 150. 30 more brings this one to our 180. 30 more is now 210. 240. 270. 300. 330. So I'm just adding 30 each time. And then finally, if I went through a whole circle, we'd be at the 360. So if I were to now have to do these all in radians, when I start, I'm at 0 radians, or 0 pi's. If half of the circle is pi, the top half, if you were to count, would be in 1, 2, 3, 4, 5, 6 pieces. So one of them's a pi divided into 6 pieces. So this is pi over 6, which is 30 degrees. And then this is something important to know. Pi over 6 is 30, but pi over 3 is 60. Because when pi was cut into 3 pieces, each one was 60 degrees. So it's like the opposite number. So now if I come here, I have 2 pi over 6s. But I'm going to write this in here because 2 pi over 6 will reduce because 2 divided by 2 just becomes 1 pi. And then 6 divided by 2 becomes 3. And of course this is a pi over 3, right? 2 pi over 6s was just 1 pi over 3 because it's in the same spot as the 60 degrees. Now this would be 3 pi over 6 because I'd have 3 of these little pieces. However, if I reduce this, 3 can divide by 3 and become 1 pi. And 6 can divide by 3 and become 2. So this is a pi over 2, which if we were to scroll up, this up and down line is a pi over 2. No matter which way we do it, it was pi over 2 here, it was pi over 2 here. When it reduces, it's always pi over 2. Because 90 degrees is the same as pi over 2 in the reduced form. This is 4 pi over 6 because it's the fourth little piece. But again, it reduces because when you divide 4 by 6, or 4 by 2, you get 2. And when you divide 6 by 2, you get 3. Because while this was 1, 2, 3, 4 pi over 6s, it was also 2 of this pi over 3 spaces. If like that length plus that length, it's 2 of those. Just like above, how is 2 of them? This is 5 pi over 6. 5 pi over 6 does not reduce because there's nothing that divides into 5 and 6. This would be the 6 over 6 one, but 6 divided by 6 just becomes 1 pi, like it says on the line, because this is always 1 pi. This is 7 pi over 6. There's nothing that divides by 7 and 6, both of them. This one is 8 pi over 6. However, there is a number that divides both into 8 and 6, and that's 2. So when I divide 8 by 2, I get 4 pi. And then when I divide 6 by 2, I get 3, because this is also a part of the pi over 3 circle. 9 pi over 6 also divides or reduces. 9 pi over 6, they both divide by 3. So if I divide 9 by 3, I get 3. And if I divide 6 by 3, I get 2. All right. If I go again, I get 10 pi over 6, also both reduces, because you can divide both 10 and 6 by 2. So if I do 10 divided by 6 becomes 5, or 10 divided by 2 becomes 5. And then when I do 6 divided by 2, I get 3. So this is the same as 5 pi over 3s. It's in the same spot as the one above. And then if I go one more, it's 11 pi over 6, and nothing reduces that. So that's just what this one's called. And now we almost have the full unit circle with these dividing in 12. All we're missing is the 45s. The ones that would have been right here. Like I did that terribly. It would just be right in the middle. And then there'd be one here for the next 45, and then the next one, and then the next one. So putting it all together, and I just gave them to you. All together, this is the degree one. Here's all the pi ones. Knowing all that matters from this whole set of notes that you've watched for like the last 15 minutes is that these two things exist, and understanding why they exist and how they exist, and that they relate to each other. That pi over 6 is the same thing as 30 degrees. And that 210 degrees is the same thing as 7 pi over 6. You could use these two charts always and forever now that you understand the way they work and what they mean and how they're the same thing. One's just in degrees and one's just in radians. Note that when I'm talking about the angle, like the angle 360, if I were to draw it, I would have to start here. Let's see if I can maybe read. I would have to start here at 0 degrees and have like this line. And then I would need my ending line at 330. But then it's not in between here and here. That's the 330. This is actually only 30 degrees between 330 and 360. But the whole 330 would be starting here and going all the way around to here. That's the angle 330. Is when you start at 0 and go all the way around. So not between here, but between the outside piece, basically. Because you always start here and then move counterclockwise around the circle to get your degrees. And so what the worksheet would expect of you, what the test would expect of you, is to be able to convert. Like if I said something was 500 degrees, could you tell me how many radians that was? Or if I told you something was 6 pi over 4 radians, could you quickly tell me how many degrees that was without necessarily looking at this chart? And so here's how we do it. Here's the radian to degrees equivalency. I'm going to just go from here with the most basic one. 0 degrees is 0 radians, right? Is 0 pi's. The next one was that a pi over 6 was 30 degrees. 30 degrees is a pi over 6. The next one, that the pi over 4 was 45. So 45 is a pi over 4. Next, pi over 3 is 60. Next, pi over 2 is a 90. Next, I don't want to do this one because 2 pi over 3s, I already know what a pi over 3 is. It just means I have 2 of them. I already know what a pi over 4 is. I have 5 pi over 6s. I know what a pi over 6 is. But here's just a pi at 180. So let's go ahead and add that one into 180 is just, all right. And now we have all of them, like all of our basic ones, just 1 pi over 6, 1 pi over 4, 1. Oh, wow, I repeated this one. Why? I don't know. There you go. Okay. 1 pi over 4, 1 pi over 3, 1 pi over 2, and 1 just pi. So those are the equivalencies, which means if I want to go from degrees to radians, I have 315 degrees. I have to guess, which one do I think it is? Do I think it's a pi over 6? Meaning that I could divide 315 by 30. Let's try it. 315 divided into 30s. It would give me a decimal, and I don't want decimals. It ends in a 5, and most things that end in 5 can be divided by other things that end in 5. For example, 45. So I might think that this belongs to the pi over 4 family. So if I do 315 and divide it by 45, I find out I get 7 45s, which means 315 degrees is the same thing as having 7 45 degrees. However, each 45 degree, remember, is a pi over 4, which means I have 7 of the pi over 4s, which means that this is the same thing as having 7 pi over 4s. And that's it. Now my radian, or my degree is in a radian, because I figured out I could divide it by 45s. I figured out how many 45s went into 315. That's 7 of them, and 45 is a pi over 4. So 315 is the same as 7 pi over 4s. And if you look up at the unit table, 315 is right here. So is 7 pi over 4. It's in the same exact spot on that unit circle. All right, 600. I think easily 600 of my 3 choices. I'm sure it could be divided by a lot of things, actually, because I could divide it by 30, sure. But can I divide it by anything bigger than 30 of all my choices? 45, maybe. Let's check, because you always want the biggest one. 45 is a decimal. 60. 60 divides. What about 90? Decimal. What about 180? Decimal. But for sure 60. So that means if I divide it by 60, I'd get 10 of them. So having 600 is the same thing of having 10 of the 60s, which is the same thing then in radians as having 10, and a 60 is a pi over 3. Now let's pretend you didn't see the 60. Like, let's pretend the first thing you saw was like, oh, look, I can divide it by 30, so I'm going to use the 30. Well, if I took the whole 600 and divided by 30, my answer is 20, meaning that I'd have 20 of the 30s, meaning that I'd have 20 of the pi over 6, because the 30 is a pi over 6. However, both 20 and 6 can reduce. You can divide both 20 and 6 by 2. And if you divide 20 by 2, you get 10. If you divide 6 by 2, you get 3. So even if you do it this way, if you try to reduce your answer at the end, you're going to end up with still the right answer, the 10 pi over 3. So no matter what you do, always ask yourself, can I reduce this fraction? And remember, reducing means, is there a number I can divide into both the numbers? And then it will become smaller. Like 7 and 4, there's no number that divides 7 and 4. So that's like the most reduced form of that fraction. All right. Next, this one is negative 510. So the fact that it's negative only means that it's negative, whatever it is. And then so if I'm going to start with 510, 510 degrees, I'm going and try to divide it by 30. Oh, cool, it divides by 30. I could try the rest. 45, no, 60, decimal, 90, decimal, 180, decimal. So I know the answer is 30. And so I have 17 30s. So it's negative 17 of the 30s because the original degree was negative, which means in radian form, once I turn it into a fraction, I have negative 17 of the pi, and 30 is pi over 6, right? So negative 510 degrees is the same thing as negative 17 pi over 6. For 405, I'm going to start with 30 again. Decimal, 45. 45 works, so it's 9 45s. So 405 is 9 of the 45s, which then means that as an answer, it's 9 pi's over 4, because 45 is pi over 4, and there's 9 of them. So that's how we go from the degree to the radian. If I want you to go from a radian to a degree, it's almost simpler. Here, I'm going to copy this little chart for a second, because you don't even have to divide to figure it out. You simply replace whatever the pi over blank is with what its degree is. So I have 5 pi over 4s, but a pi over 4, I look at its degree, is 45 degrees. And so then if I just do 5 of the 45s, it's 225 degrees. And that's it. So for negative 14 pi over 3, negative 14 times a pi over 3 is worth 60 degrees. So then if I do negative 400 or 840 degrees. Do a couple more examples real fast. Negative 8 pi over 6 times negative 8. A pi over 6 is worth 30 degrees. So negative 8 times 30 ends up being a negative 240 degrees. And for my last example, 21 pi over 2s means you have 21. A pi over 2 is worth 90 degrees. 21 times 90 I get 1,890 degrees. That's how you convert from radians to degrees. So this is the math part that you need to know how to do. The rest of it was just for understanding.
So that's the gist of the lesson. It's probably easiest to go between radians and degrees by using the formulas that I gave you at the end of that lesson. However, you also have the unit circle as a tool to understand how they all relate to each other. So why don't you go ahead and try to use if-then statements as well as these vocabulary words to explain what you actually learned how to do in this lesson.